Hi, my name is Ian Lake, and I'm an engineer on the Android Architecture Components team, and I'd like to share a few tips for navigating navigation. Specifically, I'll share a few of the best practices around using the navigation architecture component and how recently added functionality can make some common tasks and some tricky cases much easier to handle. The navigation architecture component serves as a framework for navigating within your app. It consists of three major pieces. You can think of the navigation graph as the map of your app. In Android Studio's navigation editor, you can visualize each of the screens as destinations in your graph. Actions link these destinations together and denote how the user can navigate between destinations. The navigation editor's split mode lets you see the visual graph of your destinations and the navigation XML file it's based on side by side. But navigation also supports programmatically building your navigation graph via a Kotlin DSL. Either way, that graph needs to be associated with a nav host to actually be displayed to users. The nav host serves as the container within your activity where the destinations in your graph are shown. This provides a clear separation between global UI, such as a bottom navigation bar or navigation drawer, and the views associated with just a single destination. And finally, the NavController is the heart of the navigation architecture component. Each nav host has a separate NavController that is responsible for managing its destination backstack, and it's the NavController that you use to navigate between destinations and listen for navigation events. Another key feature the NavController enables is the ability to deep link into a specific destination. An Android app isn't just a single entry point from a launcher icon. It has notifications, app widgets, conversation bubbles, app shortcuts, and web URLs that should all take the user directly to where they need to go. Because deep linking is such an important, foundational piece for making your app feel like an integrated part of the user's device, navigation has made significant progress in expanding the types of deep links supported. Associating one or more URIs with a destination was the first type of deep link supported. While the first release of navigation focused on the path part of the URI, Navigation 2.2 expanded to also support arbitrary query parameters, allowing you to extract arguments from the values provided there. But URIs aren't the only type of deep link the Android system uses. Take, for example, the action send intent. This type of intent is used by camera and gallery apps to share an image out to other apps. It requires that your app say that it supports that specific action along with what MIME types you support. With Navigation 2.3, deep link support has been further expanded to support deep links that rely on actions and MIME types. To take advantage of this functionality, you add the deep link element to your destination just like with the URI. But now you use the app action and app MIME type attributes. Then your destination can check whether it was triggered by that deep link by looking at the key deep link intent. If the action matches, you can extract the URI of the image shared to your app. The perhaps most conspicuous part is what you don't have to write. There's no logic needed in your activity at all. Navigation handles routing the user to the correct destination, and all the logic needed to handle the incoming deep link is encapsulated in that single destination. So deep links provide a way to get users to the correct place in your app with the information, in the form of arguments, needed to provide the right context. But what if that's not enough? What if that destination requires that the user is logged in? Deep links are one of the reasons why the principles of navigation specifically state that login shouldn't be used as the start destination of your app. Deep links mean your app has multiple entry points, so users won't always see your start destination as their first screen. Android itself will restore users back to exactly where they were, even if they deleted their account or changed their password online, invalidating their login. And not to mention that your start destination is what's automatically put on the backstack when you deep link. Hitting back and seeing your login screen isn't a good look. So what are you supposed to do? Well, if you can be restored at any destination by the Android system, then each destination that requires login needs to conditionally, i.e. only when necessary, navigate to your login screen and ask the user to log in. If the user logs in successfully, the login screen gets popped off the backstack and ta-da! You're back where you were with no state being lost. But what if the user chooses not to log in at all? This is where Navigation 2.3's ability to return a result can be useful to distinguish these cases. Let's take a look at what this logic looks like, starting from your login destination. So our login fragment can be called from potentially many destinations. How do we know where to return a result to? Here's where the Navigation 2.3 API of previous backstack entry comes in handy. It will always return the previous nav backstack entry, the class that encapsulates all of the NavController specific state for the previous destination. From there, we can get a reference to its save state handle. It provides us with a key value map that has two important qualities. It survives configuration changes as well as process death and recreation, so you never lose results, and it's observable, a fact our other destination will take advantage of. So with the save state handle of the previous destination, we can first set an initial state. This is the state that we want to return if the user were to immediately hit the system back button. Here, we'll set the login successful value to false. Now, after some view binding code and server verification code that has nothing to do with navigation, we finally get to the point where the user has successfully logged in and we've updated the user repository with the new user information. We do two things at this point. We set our login successful value to true, and we call pop backstack to return to where we came from. That's all we need to do on the login destination side. Let's see what needs to be done on the other side. So on our other destination, let's say the edit profile fragment, we require login. How you structure your checks on whether the user is logged in is up to you. But let's assume there's a user repository that delivers a flow we can collect to get our current user. If the user is null, we redirect users to the login destination. Just a simple navigate call is enough here. To listen for results, we can use the other helper method in Navigation 2.3, current backstack entry, since we want to get the results out of our backstack entry. We get the same save state handle that the other destination is going to put the result into, and we call get live data to get an observable stream. The callback here won't be triggered until the other destination puts a result in and we return back to this destination. What you do in your callback on failure is a business decision on your part. You could consider making an overlay visible, explaining why login is necessary. Just finish the whole activity if every screen requires login. Or do what we do here and navigate back to the root of our graph, resetting the users back to our start destination. This would be appropriate if your start destination does not require login. I know. There's a lot going on behind the scenes. Now, we've written tests for navigation's logic, but it was also incredibly important to us to enable you to write tests for your destination's logic. The navigation testing library, released in Navigation 2.3, provides a test fake in Test Nav Host Controller. The Test Nav Host Controller contains all the same NavController internal logic, which means its behavior is always going to mirror the real thing. But it differs in one important case. It doesn't actually navigate. The Test Nav Host Controller state will be updated, but it doesn't complicate your test by actually doing fragment transactions or animations, ensuring that you have a fast and reliable base for your tests. So let's see how this would work with our login fragment and ensure we can test our initial state using fragment scenario and test nav host controller. We'll start by creating our test nav host controller and calling setViewModelStore to ensure we can use the SafeStateHandle API. Since this acts just like a real NavController, we still need to call setGraph on it, passing it our real graph. However, we also get some helpful utilities like setCurrentDestination that allows us to jump directly to our edit profile fragment. Then we navigate to the login fragment we want to test. When testing our fragment in isolation, our test takes on the role of the nav host fragment, setting our test nav host controller right when the view is created. Our test for the initial state is then straightforward. We get the previous backstack entry from the NavController and check whether the value is already set to false. You could extend this with a simple espresso test to actually do the login and ensure that the state swaps over to true. Importantly, we didn't need to create fragile mocks, and we didn't need to warp our code to test your business logic's intersection with navigation. Letting you own your unique business logic is a really important factor for navigation. But for some cases, it really is just boilerplate. Dynamic feature modules are a really powerful way to deliver features just in time through Google Play. But if those features involve one or more screens in your app, coordinating the download, install, and display of those screens isn't necessarily straightforward, unless you're using Navigation 2.3's support for dynamic feature modules. If you're already using a nav host fragment, adding support for destinations provided by a dynamic feature module involves just a few steps. First, add the navigation dynamic features fragment artifact to your build.gradle file. Then swap out your nav host fragment for a dynamic nav host fragment. With only those two changes, you can now add destinations from dynamic feature modules to your navigation graph. Just add the module name attribute, and navigation will take care of installing your module, if needed, before navigating to your destination via a progress destination. Loading a whole navigation graph is also supported via the include dynamic tag. While there's a lot of new features already in work for future versions of navigation, everything I've talked about here is stable and available right now. So look through our updated documentation on developer.android.com and check out the releases page for more details and links to the issue tracker for filing your own feature requests. Thanks.